Okay.
Okay, students, I decided the best way to kind of wrap up a lot of all that chapter 5 is talking about is by doing homework 5.2.1a. It's one of those problems in your homework worksheets. I'm going to work through A through F, talk things through, and then I will expand on that to show you guys other things that I need you guys to make sure you're practicing on. So let's go ahead and work through the problem, and let's see how this goes in helping you. So the first thing that they wanted us to do in this particular problem was part A was to find the axis of symmetry equation. So part A was all about finding the axis of symmetry. So again, an equation that you will need to make sure to memorize. It's x equals negative b over 2a. What do those variables represent? They represent your equation that is in standard form, where a is going to be your x squared coefficient, b is the x coefficient, and c is your constant. So we are going to merely substitute x equals negative b, so opposite of b is going to be 6 over 2 times our a. We're going to simplify to get negative 1. So our final answer is x equals negative 1. I want you to please, when you are doing this problem on your test, especially if it's free response, do not just write the negative 1. I need you to make sure that you write it as x equals negative 1. An equation of a line has to either be vertical or horizontal or slanted, but as far as the axis of symmetry, we know it has to be vertical. So make sure you stipulate that by writing x equals negative 1 or whatever the number is. The next step in part B asked us to find the vertex of this parabola. Now, there are different ways you can find the vertex of this parabola, and I'm going to use the first approach that you're going to see here, and then later on I'm going to show you another approach. So because we already have what the axis of symmetry is, and we know that the vertex sits on the axis of symmetry axis, we already know that the vertex has an x-coordinate that is at negative 1. Okay? And because it has an x-coordinate that is at negative 1, we can easily find the y-coordinate because we have the equation of our parabola. The y, our output value, is found when we look at our function f and we substitute negative 1 into every x, and that will give us the y-coordinate. So let's go find this coordinate, which I know I wrote in function notation, but that's just the y, okay? So f of negative 1 is going to be 3 negative 1 squared plus 6 times negative 1 plus 11. Order of operations, anything squared is always going to be a positive value, so 3 times 1 minus 6 plus 11, negative 3 left to right, plus 11 gives us an 8. So our vertex is going to be negative 1 comma 8. Now let's go do part C. Part C required us, let me see again, they wanted us to determine whether the vertex was a minimum or a maximum. In order to determine that, you have to find what the concavity of your parabola is going to be. Concavity depends on your a value. Your a value is the coefficient of x squared. It tells us whether our graph is going to be upward facing or downward facing. In this particular case, we know that our a is 3, and 3 is greater than 0. And because it's greater than 0, it's going to be concave up. On the test, if they ask you to stipulate or justify how you know it is a minimum or maximum, this is the suggested form of a sentence explanation that I would tell you, suggest to you to do. Of course, it doesn't have to be in the exact words I'm writing, but here goes. The vertex for our particular problem, vertex of f of x, is a minimum. Because the a value is greater than 0. Thus, the parabola is concave up. Okay, so the vertex of our graph is a minimum because the a is greater than 0, which automatically implies that the graph is concave up. And that explanation helps provide a visual to show that our vertex is a minimum. Okay? Part D. I still find that many of you keep forgetting how to find the y-intercept. And I need you to please grasp this definition as soon as possible, because this is a definition that you have been working with since the first function you ever were introduced to, and that's linear functions. Y-intercept merely means the line where the graph is going to, the point where the line is going to cross the y-axis. And that point, because it's sitting on the y-axis, has to have an x-coordinate of 0. And to find that y-coordinate, we need to plug this 0 into our function to find that y-coordinate. Okay? That's all you have to do. Plug 0 into every single x. Now, if your graph is in standard form, such as y equals ax squared plus bx plus c. Oh, forgot to put the x. Okay? You can automatically see that the y-intercept will just be your c value, because this 0 being plugged in here and a 0 being plugged by here is just going to automatically remove those terms, because when you add it to c, it's just going to end up being c. So if you just remember that in standard form that it's always going to be the c value, you're good. But of course, if it's in vertex form, please make sure plug in your 0 and do the simplification. I've seen students do this. I'm going to write this down. I'm making this up completely. Let's say it's like this. Students have come to tell me, oh, the y-intercept is 0, -5. And the reason they say that is because they memorized that the c is over here on the far right, and they know that's going to be the y-intercept, and they're like, oh, this is the y-intercept, it's -5. That's just very, very bad memorization and lack of understanding, okay? It has to be in standard form for you to tell me it's the c value. Why? Because 0 squared is 0, 0 times a is going to be 0, 0 times b is going to be 0. All of that disappears. So if you recognize and understand that, then it's c. But here, that's not going to be 0. This is not standard form. That's vertex form. So you would have to substitute 0. 0 plus 2 would be 2. So it would be -3 times 2 to the second power minus 5. 2 squared is 4. 4 times -3 is -12 minus 5. Your y-intercept would end up being 0, -17 for this particular problem. Okay? Again, I just made this problem up on the spot just to make sure there's clarity The official y-intercept formula is substitute x for every x in the given function. For standard general form, however we want to call it, of a parabola, it's always going to be your c value in this form. Any other form, please substitute 0 for x. All right, so let me erase this. That had nothing to do with this problem. Okay. And our final answer for this one is y-intercept is going to be 0, 11, because it's our c value. Okay. E. E is asking us to find the discriminant of this parabola, but at the same time, when you find the discriminant, explain exactly what is the job of the discriminant. So let's go do that. Another formula you need to memorize. So b squared minus 4ac, we are just merely going to substitute what we identified as a, b, and c into the formula. So b squared, since mine are hidden, use what you have on your paper. B is our 6 all squared, minus 4, my a is a 3, and my c is an 11. 6 squared is a 36, minus 4 times 3 times 11. Well, I would, if I'm doing this math by hand, I would multiply 3 times 11 first to get 33, and then 33 times 4, I get 132. And I subtract to get negative 96. Now, if I remember my rules of discriminant, if the value of my discriminant is less than 0, therefore, this implies, the 3 dots means therefore, my function f of x has no real solutions, or no real x-intercepts. Okay, f of x, or the graph, has what we call complex roots or complex intercepts, which is what Unit 6 is all about. Okay, so this is the introduction of us working on Unit 6. All right, what does complex roots mean? What does this mean graphically? The graph has complex roots, and I could say therefore, never, all of a sudden I can't write in cursive. Therefore, never touches the x-axis. That's what it means. Okay, so your parabola is either floating high up or really low, okay, facing downward underneath the x-axis. Okay, now we arrive to the last question on this particular homework, but like I said, I'm going to give you a little bit of an extension after this. On F, it asked us to go find those roots or those x-intercepts. So when it comes to parabolas or quadratics, okay, I want you to remember, I actually am going to write this down, okay, when finding roots, when finding x-intercepts, either factor or apply the quadratic formula. Okay, so I want you to always resort to trying to factor first. Okay, always try to factor first. If you can't factor, then resort to using the quadratic formula. So here's what I mean by this. Here is your parabola equation. Let me see if I can factor. Well, 3 times 11 is 33. two numbers that multiply to be 33 that add to be 6, it's not going to happen, right? I know factoring is definitely not going to work because it already told me that it was going to be complex roots. So quadratic formula is definitely the way to go. But just in case you had not done all this that we just did beforehand, and you were just given a problem and asked to find roots, try to factor first because it's usually the faster method, but quadratic formula never fails. So practice both methods, okay? So quadratic formula is the additional method that you are going to need to practice with. And of course, please have that memorized. There's a cute video online with songs with the quadratic formula that helps you memorize it. So go on and listen to it. Maybe I'll attach it in Canvas if I can find it. So negative b, x equals, and make sure you say x equals, okay? A lot of students just start reading quadratic formula from here. That's not a formula. It's x equals. You want to identify that this formula finds your x-intercepts. Negative b plus minus the square root of b squared minus 4ac over 2a. We already know what this is. So let us proceed. X equals opposite b plus minus the square root, and we found that in part E, and that was negative 96 over 2 times a would be 6. 2 times 3. Square root of 96. So we try dividing it by all our perfect squares and see what's the highest one. I don't know how well you can see this calculator. Let's see, can you see it well enough? It seems like it's working. So let's see, 96 divided by 4 is 24. Let's try something higher. 96 divided by 2 squared, 3 squared is 9. It's not going to be divided. 4 squared is 16. So let's see, divided by 16. That works, and that looks like it's going to be as high as it gets with that 6. So 16 times 6. 16 times 6. So that means the 16 is going to come out and become a 4. So I'm going to put negative 6. Whoops, let me move this over here a second. Negative 6 plus minus 4i, because the negative is coming out, the square root of 6. So 16 times 6 is 96, right? Just in case you don't understand what I'm doing here, let me rewrite it over here. We have 96 is being factored, okay? No, that's pretty bright there. 96 is being factored as negative 16 times 6, okay? So when I take out the square root of negative 16, it's 4i, and the 6 stays inside. The 6 is only 2 times 3, okay? All over 6. These three numbers are divisible by 2. Do not touch this number because that number is inside the radical. So I'm going to reduce and write x equals negative 3 plus minus 2i over 2i square root of 6, can't forget the radical, over 3. So here are my complex roots. Okay, those are my complex roots. Okay, now the extension that I wanted to bring your attention to. So let me flip this over. I'm going to rewrite this function here at the top. F of x equals 3x squared plus 6x plus 11. Okay? Remember in part A, you were asked to find the vertex. And we use the axis of symmetry to find the vertex. You can also use completing the square. Okay, completing the square to find the vertex. So please, please, please practice using completing the square to find the vertex. So in this problem, we have f of x equals, because there is a that is not 1, so a is not equal to 1, I need to factor it out of the first two terms only. So I'm going to pull out a 3, factor it out of 3x squared, and I'm left with an x, factor it out of 6, and I'm left with a 2. Factoring just means undistributing. So you're really just dividing out. That's what factoring is, dividing out. So plus 11. So if I distributed, I would get back my original problem. That's the first step. You can never complete the square when x squared does not have a coefficient of 1. You have to have an invisible 1 here, okay? So 3, open parentheses. I'm going to complete the square inside of this trinomial. Don't skip steps. Some of you guys are getting so confident in it, you're skipping steps and making silly mistakes. I take this b divided by 2 and square it. So 2 divided by 2 is 1, and 1 squared is just 1. So I'm going to put plus 1. My plus 11 still comes down, but I must undo what I just did. I must undo 3 times 1, okay? Not just the 1, because the 3 is holding on to 3 1s. So 3, I'm going to factor this trinomial. It becomes x plus 1 all squared, and I need to make sure that I undo the 3. 3 times 1 is a positive 3, and I undid it, so that's a positive 8. So notice how the vertex is going to be opposite. X plus 1 equals 0. Do some side work here, and I subtract 1 on both sides. I get x equals negative 1. That's my x coordinate. 8 is my y coordinate. The graph went left 1 and up 8. That's what it did, transformation wise. It went left 1 and it went, not down 8, I'm sorry, and up 8. You always do the opposite for horizontal movement. You do exactly what the vertical movement says to do. Okay? All right, so notice that negative 1, 8 was the same answer we got here, negative 1, 8. Okay? The next thing, you guys need to be able to find your focus. Okay? So let's find the focus. The focus is always trapped inside of your parabola. All right? And it's always a distance of c prime from your vertex. All right, so we know that our parabola is upward facing. Okay, we also know that we have an axis of symmetry that's cutting it through. We know that the vertex is negative 1 comma 8. Okay, so we know our focus has to be inside. So some distance inside, I don't know, but here's my capital F. And whatever that distance is, the opposite distance on the outside that's perpendicular to the axis of symmetry is my directrix, dir. And it's going to be y equals some number. Okay? So I want us to do two things. Find the focus, find the directrix, but that depends on this distance, and that distance is my c prime distance. Okay? So how do I find what that c prime is? Well, here's another formula. 1 over 4c prime. What's my a? My a is 3. Okay? So I'm going to substitute that into a. And let me do it over here. 3 equals 1 over 4c prime. I am going to... there's many different ways you can solve this. I'm going to move this whole thing over. So 4c prime is multiplying. I'm going to move it over and multiply it by that. So 12c prime equals to 1. And then I have to solve for c, so I need to divide by 12 on both sides. So the distance of c prime right here and right here is 1/12 units. So if I have to find the focus, Okay? Notice that I know the focus, I have to just go up. The focus x value is still going to be the same as my vertex. So I already know that my focus has an x coordinate of -1. That's not going to change because I had to go up from the vertex. So if I'm at the vertex at 8, I had to go up 1/12 of a unit. Okay? So that means my answer is -1 comma 8 and 1/12. Or if you want to write it in mixed numeral form, it would be -1 comma 93/12, which is 8 times 12. No, not 93. What am I doing? 8 times 12 is 96. And then 96. Yeah, 96 plus 1 is 97/12. So 97/12. Okay? Now, so that I had to go up to find the focus. Here, I have to go down. So that means my directrix. Now, the directrix, just like the axis of symmetry, okay? Directrix, just like the axis of symmetry, is an equation. So I'm going to put equation here in caps because I do not want you to forget. Do not just write a number. It's a horizontal line, so you must write y equals. Our y is 8 from the vertex, and we went down. So it's going to be 8 minus 1/12. So y is going to be 7 and 11/12, or you can use your mixed numeral again. 7 times 12 is 84. 84 plus 11 is 95/12. So there you go. You have found everything that you can think of on a parabola. So I hope this brings some clarification to all that you've been doing. So my challenge to you is pick a standard form equation of your own like this and work it out entirely just like we did with this one problem. And just get acquainted with the formulas and the questions that you have to self-talk to yourself throughout the test. Thanks for watching.